quick introduction to our system. Tagged bottles oriented at various angles are covered by a white box which the person doing the experiment is not aware of. As can be seen now, the detected angle and the actual angle at which the bottles are oriented are almost same. We exploited the concept of polarization in designing our system. The transmitter is rotated and the receiver is fixed. With the varying angle of rotation like 0, 45 and 90 degrees, the power received by the dipole doesn't change in case of circular polarization. Here, in linear polarization, with the varying angle of rotation like 0, 45 and 90 degrees, the power received by the dipole does change. With this idea in mind, we conducted experiments with linearly polarized tag and linearly polarized reader antenna as well as circularly polarized reader antenna. The plots obtained after conducting the experiments clearly indicates that the received power remains constant with changing angle of rotation in case of circularly polarized reader antenna, while varies considerably in case of linearly polarized reader antenna. From this we conclude that detecting angle of orientation with linearly polarized antenna is indeed possible. Now coming to the antenna design. For the system, a simple, robust, low profile and compact antenna has been designed. High impedance surface has been used as a reflector which works as perfect magnetic conductor, thus can be kept very close to the antenna without shorting it out. The two layers of high impedance surface is separated by a 1.6 mm thick layer of FR4. Metal patches provide capacitive coupling with nearby patches on the same layer as well as due to overlap of patches on the other layer. Inductance is obtained due to current path formed with metal ground separated by another substrate layer of 3.2 mm thickness. On the top, a bow tie dipole is kept at a height of 1.6 mm from high impedance surface. All three layers are put together and thus a planar compact antenna is ready. Radiation pattern and reflection properties are measured inside the anechoic chamber. Impedance bandwidth is 11.55%. Antenna has a cross-polar level of 20 dB throughout the frequency range. RFID reader assembly. All these are put together and fitted inside a box and the device is ready to use. Antenna is attached via an SMA cable and holder. This is the final look of our compact and simple RFID reader. Android application. The list of tag items stored on a computer is transferred through Wi-Fi to the Android device. To load a fresh list, press import or press load last imported list to use a previously stored list. This is the main screen of the app. Orientation sensors of Android device are used to calculate angle of reader. Steps to follow for computing angle. Press start to start inventory. As tags are red, read count increases. Tags red are in green and those not red are in red. Press stop to stop inventory. Calculate angle button becomes active after the inventory is stopped. Press calculate all to get predicted angle. The graph in green indicates raw data and the one in blue indicates filtered data. We use intelligent algorithms to filter the raw data to generate accurate results. Press save button to save results to database. Press reset for conducting a new experiment or to discard existing results. We have structured the scenarios to give an overview about how our system behaves when it transitions from a simple to a complex environment. Scenario 1. The simplest of all. Tagged empty bottles kept on a table. Case 1. All bottles at 0 degree. Case 2. 2 bottles at 0 degree and 2 bottles at 90 degree. Scenario 2. Tagged water-filled bottles kept on a table. Case 1. All bottles at 0 degree. Case 2. All bottles at 90 degree. Our system gives fairly good results with tagged plastic bottles. Scenario 3. Now we tag metal cans. Case 1. All cans at 0 degree. Case 2. One can at 0 degree and one at 90 degree. Scenario 4. We take our system to even more complicated environment. We keep tagged empty bottles on the topmost rack of a metal trolley and examine various cases. Scenario 5. Finally, we put our system into an extremely challenging situation, keeping bottles on both the top and middle rack. Case 1. All the bottles at 0 degree. Case 2. One bottle in each rack at 90 degree and the other at 0 degree. Conclusions drawn from all the scenarios are presented in the form of a graph, which indicates that the accuracy of the detected angle decreases as we move from simple to complicated scenario.